I recently picked up a machine off of eBay that was listed for parts or repair. I have no idea what kind of condition it is in, so let's see if we can get it working, starting with the power supply. Since I've not had my hands on a Commodore 64 since the late 1980s, I'm starting from scratch. I'll need to have a reliable power supply and a display solution before I can even test it. I do have some common parts and a cap kit on order, along with an unknown condition 1541 I picked up at the Retro Gaming Expo in Portland, Oregon. The original power supplies from Commodore have a high failure rate and can sometimes supply too high of a voltage on the 5-volt side that can fry many chips, especially the RAM. This computer came with an aftermarket supply, but when I tested it there was no 5 volts at all, even under load. Even though it's an aftermarket supply, it still suffers from the ill-advised epoxy potting that most of the original power supplies had. This makes repair virtually impossible, so I've decided to build a new replacement power supply and will only be reusing the cords from this unit. For the 5-volt DC supply, I purchased a switching supply on Amazon. The Commodore 64 requires at least 1.5 amps, and this Meanwell RS15-5 can output up to 3 amps, so it should do nicely. I also purchased a 9-volt AC wall wart at my friendly local electronics supply store. The Commodore requires 1 amp, so this 1.1 amp unit will fit the bill. Finally, I picked up this supply enclosure, which will fit everything quite nicely. I'll start out by checking the continuity on the cables I'm reusing. I added some extensions to the power cable, since they were very short, and attached the AC in and ground wires to the 5-volt switching supply. Next, I checked the AC cable for continuity and shorts. I typically double check everything as I go along, since it takes a lot longer to troubleshoot issues later. I created a worksheet to make sure I wire things up correctly. There's a lot more going on than one would think for a supply that only puts out 2 voltages. 5 volts DC is provided at 1.5 amps to power the microprocessor logic chips, including the CPU, RAM, and most other onboard chips. 9-volt AC is provided at 1 amp, which the motherboard uses to produce 3 supplies. 12-volt DC is generated for use by the VIC and SID chips, as well as the audio amplifiers. A second 5-volt DC supply, called 5-volt DC CAN, is individually filtered for the video circuits and the clock circuits. Unregulated 9-volt DC is used for the cassette motor circuits and the RF modulator on some 64 versions. Finally, the unaltered 9-volt AC is also made available on the user port. I created this document with the power port and connectors to show how everything would be connected. I'll quickly map the DIN connector wiring and record the wire colors on my worksheet. I will include a link to the blog post with this reference along with other details on making your own supply. The existing wires are old and oxidized, so I cut them back for easier soldering. While I generally avoid tinning wires that will be in a compressed connection, I like to tin just the tips to keep the wire strands together. For the 9-volt AC, I just solder the wires together as a pass-through and insulate the connections with heat shrink tubing. I connected the new power supply to the AC mains and checked the voltages. I immediately found an issue with the 5 volts. There's virtually no voltage here at all. I checked the AC voltage just to make sure, and it was just fine at 122.5 volts. It turned out I was misreading the markings on the Meanwell supply. I expected plus 5 volts between the ground and the plus V terminals, and negative 5 volts between the ground and the minus V terminal. It turned out there is plus 5 volts between the minus V and the plus V terminals. Oops! After reconnecting the wires, everything looks good. The 9-volt AC was measured just over 11 volts, but this is expected since there's no load on the transformer. Looking at the Meanwell RS15 datasheet, I noticed that the overvoltage tolerance was a bit higher than I like. The cutoff is at 5.75 to 6.75 volts, which is more than enough to damage a Commodore 64 if the power supply failed. To protect your computer from a failing power supply, there are a couple options. Ray Carlson created the Commodore 64 Saver. You can get a cable version that is used on your existing power supply and will protect any computer that power supply is used on. You can also get a version that's installed inside a computer, which will protect that computer from any power supply. I will include a link in the description to Ray's library of invaluable repair information. Okay, now for the moment of truth. Let's turn it on and see if it works. Hey, we got a red light, that's a good sign. Now that we know the power supply works, we'll assemble it in a case. These are small dampeners that go in my cupboards, and they just prevent the cupboards from slamming and making noise. We'll add our RavenWolf seal of approval, and then it's done. Testing the computer on our TV, I can see that it works. When I first tested it without the video running, there was character corruption and the keyboard is not very responsive, but it does come up and I do have a flashing cursor. For my next video, I will be making an S-video cable, which will go to this HDMI box. That way we can test the machine on a regular monitor and not a 60-inch TV hanging on a wall. If you like this video, please give it a like below. Click the RavenWolf logo to subscribe, and here's another video you might like.